broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to GridGain Systems webinar, part 1 in memory computing for architects and developers. I'm Nicole van Geleur and will be today's moderator. Before starting, I will need to conduct a little housekeeping. Can you raise your hands? And the icon on the left of your screen if you can hear me. I see one show of hand. Anyone else? Perfect. I think we're good to go. On behalf of today's webinar presenter, thanks for joining us. I'd like to introduce our speakers for today. Akmal Chaudhri is a technology evangelist at GridGain. His focus is on Apache Ignite and the Apache community. If at any point during the webinar you have a question, please type it in the Q&A panel. Questions will be addressed at the end of the webinar. Please also note that your phones will be muted throughout the presentation. You've joined us today to hear about the essentials of in-memory computing for architects and developers, and we are presenting part 1 in our two-part series. At the end of the webinar, we'll close out by taking your questions. With that, I'd like to turn things over to our product expert, Akmal Chaudhri.
Okay, well, thank you, Nicole, and thank you, everyone, for joining this morning. So we tend to get people joining from all over the world sometimes when we run these events on sort of US time. So I guess good morning, good afternoon, good evening, wherever you are in the world. And thank you very much for joining us today. Hopefully this will reach a good European audience, which is, I think, primarily why we're running it at this particular time. Okay, so my role, as Nicole mentioned, so it's to help really raise awareness of Apache Ignite. So I focus principally on the open source technology, and if there is interest in some of the commercial product offerings as well, I'm very happy to discuss those with you offline. We can do that, no problem. If you need to reach me, it's very simple. It's just my first name dot last name at gridgain.com. So that's akmal.chaudhri@gridgain.com. Okay, so feel free to reach out to me, send me an email if there's anything further I can help with, assist with today. So the slides will be available later, and the webinar recording will be available later as well. So those two things. But if there's any further follow-up that you would like, please reach out and get in touch with me. Okay, so let's just switch to full screen here. Hopefully you'll be able to see that. So this is the first part of this two-part series, and I believe we're running the second part next month, towards the end of next month. So July, August tend to be a little bit quiet time sometimes, you know, because of vacation, but we feel the timing should be good for people to be able to attend and join us for these two events. All right, so in terms of agenda then for this first part then, so what I'll do is a little bit of an overview of Ignite, discuss its key components, look at its history to some extent, where it's come from, and then look at some of the capabilities that they've added, particularly this last year or so. Then we'll drill down into a couple of these areas. So clustering and deployment, distributed storage. We'll talk briefly about distributed SQL as well, and then hopefully leave enough time at the end for some Q&A. And again, if there's anything that I'm unable to answer, we'll be happy to follow up with those later on. I've got some demos as well, which I'll try and show all the way through, and I will give you the hyperlinks as well, and to show you where you can actually get the code, and if you'd like to try and run these examples for yourselves. So that will be fairly easy. Okay, so let's begin with this. So this is the kind of high-level architectural view of Ignite, if you like, you know, the 30,000-foot view or the 50,000-foot view, as they say. So notice it says that Apache Ignite database, caching, and processing platform. So historically, where Ignite came from was a donation by GridGain to the Apache community, and Originally, this was classed as an in-memory data grid. Okay, so there are other commercial products that are IMDGs as well. But particularly this last year or so, I mean, Ignite has really gone far beyond that. And we'll look at some of these capabilities today, and then some more in the second part of this two-part webinar series. So at its heart is this memory-centric storage, which you see. So this really comes from its historical roots as an in-memory data grid, where it was really designed to address two key problems. First one was scale, and the second one, performance. So the scale allows us really to add additional nodes. We can build out a cluster, as many additional resources as we need. And then the performance, obviously, because now using cluster computing, it means that each of those nodes can do some part of the processing. And that means that we can divide and conquer. So if there's a big processing problem, it can be spread across the various cluster nodes. Now, caching is one of the capabilities that Ignite does very well, but it's not just for caching. So you'll see the caching is mentioned as part of the title for this slide. But additionally, database capabilities, okay, we'll talk a little bit about those today, and then the processing capabilities as well. We'll say more about that today and in the second webinar. So memory-centric storage is key to this. Now, one of the things that Ignite can do very well, if you look in the bottom right-hand corner, there's this third-party persistence that you can see. So we've got relational, HDFS, NoSQL. So Ignite can work very well with, particularly with transactional database systems. Typically, today that means relational. Majority of NoSQL systems tend to be kind of eventually consistent. It's a little bit harder to cope with, although some of them do offer ACID capabilities and are transactional as well. But if we focus principally on relational just for the moment, okay, then it makes it a little bit easier to kind of explain how this works. So one of the things that we may have, and which is fairly common in a lot of organizations today, is that there is a business problem. People are, Postgres, MySQL, Oracle, if you're using these types of relational systems, these are fairly common. They are very good general purpose database engines used for a wide variety of problems. Often some users find that perhaps there are some queries that don't work particularly well with these systems, but for business reasons they need to use these and continue to use these relational database systems. This is a great kind of use case for Ignite, because what Ignite can do then is it can work with that relational system. It can cache the data. It can use this scale and performance to improve the responsiveness of certain queries which may not be working well otherwise. So in that way, you keep your investment in what you already have. So there's no kind of rip and replace, which is one of the key strengths that Ignite provides. At the same time, then, what Ignite provides is the capability to work with that transactional system in the way that if there are changes in the database system, Ignite can see those changes. They are reflected in its cache that it maintains. Equally, if we update the data that's in the cache, in this kind of memory-centric storage, then those changes are reflected back in the back-end relational system as well. So the two are kept in sync, and this provides sort of great advantage and great benefit. And then just in a moment, before we move on to the next slide, I will actually show you where you can find some additional information. 10 minutes of your time, there's a couple of videos that you can watch from the Ignite website, and I'll point those out to you momentarily. Okay, so it works well with third-party persistence, works really well with transactional systems in particular, but can work with other systems as well, such as HDFS, NoSQL. Now there, the guarantees are not the same, obviously, because, as I said earlier, some of these systems are eventually consistent, work slightly differently. One of the other nice features that they added last year, if we look at the bottom left then, is this Ignite native persistence. So the idea here is that in this mode, Ignite can persist the data beyond the lifetime of the process that created it without you requiring some third-party persistence to manage that data for you. So Ignite can persist that data for you. It can do that. And And it can do that using these kind of modern flash and SSD technologies, which will provide great performance as well. So in this scenario, for example, if we've got large quantities of data, say we've got a petabyte of data, it's highly unlikely that we have the ability or the cost effectiveness of wanting to cache all of that data. Now, in some circumstances, organizations may want to do that, but those tend to be like the Twitters and the Facebooks and the Googles of this world, who may need those kind of requirements. But for a lot of business use cases, we may have a large quantity of data, but perhaps only need to cache a part of that. So in this scenario, we can let Ignite manage that data, persist it, and cache what it needs to cache as our access patterns require data to be paged in. Ignite will do that for us. Okay, so it will take data from storage, page that into memory. We can run our queries, and that's transparent and totally managed by Ignite for us. So for the developer's perspective, it's not something that he or she needs to worry about. Okay, so a very useful capability. So this persistence mechanism was added last year. They worked on it, and it gives you a lot of scale and the opportunity to store vast amounts of data if you need to, and keep that persist it beyond, as I said, the lifetime of the process that created it. And again, you get other benefits as well, because if we have some serious kind of cluster failure, and recovery can be very, very fast as well. So there's a couple of features we have, like a write-ahead log, for example, partition files, all of these things that are maintained. So each node in the cluster maintains some small part of the data of the overall cluster, and therefore the ability to bring a system back up again is going to be really, really fast, because it's got information available in terms of the logs and the partition files to allow us to do this. Okay, so looking at the slightly higher then, at the level above the memory-centric storage, then working from left to right, then so we've got SQL support. So Ignite has had some level of SQL support for quite a long time. But again, last year, particularly the focus was adding SQL 99 support. Now, the thing is that whether you like SQL or you don't like SQL, the fact of the matter is that it is intergalactic data speak. It is very widely used. A lot of BI tools, for example, and it's very easy to find good skill developers as well that have SQL skills. Now, I appreciate, there are sort of dialects, different vendors implement different subsets of the language, but generally speaking, it is sort of fairly easy to transition from one version of SQL to another version of SQL. So, for example, ANSI, ISO supported SQL 99. It's fairly standard and fairly well supported by the majority of database vendors on the market today. It's a very useful capability. We'll look at that a little bit later on, very briefly. Key value. So at its heart, again, from its origins as an in-memory data grid, Ignite supports key value. And the value can be anything. So it can be simple types, for example, character, string, floating point, so on, or can be complex types. Okay, it could be something like a financial instrument, for example, or a healthcare record. And the way that Ignite works, and we'll look at this very shortly, is that it knows the cluster resources that the nodes that it has available, and when it needs to figure out where to store the data, a hash algorithm is applied to the key, and then this provides an address within the cluster where it knows where to store the primary copy of the data. So Ignite is a peer-to-peer system. Okay, there is no master as such. We can have like a primary copy of the data, and typically in a distributed system, we will probably keep a backup copy as well. So in the event there is some failure, some part of the cluster goes down, we can still access the data. And again, we'll look at this very shortly. Moving on, so transactions, very useful, and again, beyond the capabilities of just a simple sort of caching technology. So now I'll give you an example from my sort of personal experience, not directly related to Ignite, but again shows the value and the utility of using transactions. So I'm a great fan of MOOCs, massive open online courses. So I like to take these online courses because they give me the opportunity to pursue some interests or some training that I would like to get. So some months ago, I was on the website for one of these MOOC providers, and there was a particular course that I happened to think that I would like to take, and I would like to get the certificate for this. So I get my credit card out, put my details in, and I hit the pay button. And then it came back and said, there is an error. And I didn't think too much about it. I thought, okay, you know, it's an error, transactions failed, no big deal. Okay, sometime later, I'll try again and leave that for now. What happened, though, was that a while later, I checked my bank credit card statement, and I noticed that I'd actually been billed. So although I was shown that there was an error on the website, the transaction itself had completed. It had gone to the bank. So the bank thought that, it's successful. They billed me. I went to the merchant, the MOOC provider, and I said to them, well, look, the money's been paid. And they said, we haven't received the funds. You need to talk to your bank. So I'm kind of left in the middle now. So the merchant says they haven't been paid. The bank has billed me and says, yes, you've paid for this service. Now it's left to me to sort this problem out. So in this case, use of transactions in the sense that we have the system moving from one consistent state to another consistent state, it would be very, very useful. So there was a kind of a poorly designed system that the MOOC provider was using. Now, had they designed this properly, so at the moment when I entered my credit card details and hit the pay button, and it said there was an error, then that was fine. The transaction should have been rolled back. I shouldn't have been billed. So Ignite supports these kind of pessimistic transactions, lock-based, okay, which if you've worked with relational or other database management systems, that these type of capabilities allow the system to complete a set of operations in full or not at all. Okay, so for example, a classic example that we use is transferring money from one bank account to another. So if I want to transfer some money from my bank account to my wife, for example, the system must ensure that my account is correctly debited and her account is correctly credited. We can't have the situation where the money leaves my account but doesn't reach her account. I mean, that is not allowed. That doesn't leave the system in a consistent state. So Ignite does these lock-based transactions. It also supports optimistic lock-free transactions. So there is a kind of a very useful transaction mechanism for another type of problem. Okay, so in, for example, computer-aided design, computer-aided manufacturing, we may often have a designer where he or she copies some part of some design from a central repository onto their local workstation. They will work on that design, and then sometime later they will check that design back into the central repository. Chances are, because they are working on some specific part of the design, there is, the opportunity for conflict is going to be very small. The likelihood that they're going to interfere with what somebody else is doing is going to be very, very small. So there, we kind of don't need the overhead of lock-based transactions, so we can use these kind of lock-free transactions. And again, Ignite can handle situations where you may have some resource contention. For example, in locking scenarios, one process may be holding a particular lock, another process may be waiting to obtain that, and it holds something that the first process needs. So this kind of scenario of deadlock, Ignite can handle these situations as well. Gives the developer control over what action to take should this type of situation arise. Okay, so you've got a lot of flexibility. So transactions, extremely useful, and particularly I think for some application domains, this is a must. Okay, so in the financial world, for example, very important when you're dealing with huge sums of money that are being transferred, and you're dealing with these situations where it's important that the system moves from one consistent state to another consistent state. Okay. Okay, compute and services. We'll look at compute a little bit later on. Services we won't really discuss today, but perhaps we'll do so in part 2. Streaming, briefly, I'll just say a little bit about this. So Ignite does not provide streaming per se. I mean, it's not a streaming engine, but it has connectors and adapters to work with other streaming technologies. So, for example, if you are a Flink user or you are working with Spark Streaming, Ignite can integrate with these technologies very well. So in this kind of scenario, for example, and we've got some demos as well, and again, I'll point out where you can download these momentarily. So a good example might be, say, sensor data or IoT type data. So this might be coming in from a variety of sources. So you might apply some streaming engine to manage that, and then Ignite can then act as a kind of a sink. So that data streams in, Ignite can store that data, or it can process that data. We can define a kind of a window, if you like. So perhaps we're interested in the last 5 minutes worth of data, or perhaps we're interested in the last sort of 50 events or something like that. We have a window. As the data arrive, we can process that data. We could run some SQL across that data, for example, for analytics, or we could do some machine learning, for example, and either we can decide to store that data for historical reasons or legal reasons if we need to, or we could just ignore it and get rid of it and then wait for the next sort of batch of data to arrive. So in that scenario, again, Ignite can work extremely well with these streaming technologies and streaming engines, and act as a kind of a sink for the data. And again, it not just cache the data, but offer additional processing capabilities beyond just simple caching technologies that are out on the market. And then the last thing there, which we have on the right-hand side, is machine learning. So again, the machine learning was in beta last year, and it's gone GA now. And really, there is support for a variety of machine learning algorithms. I've just recently been working on a series of articles covering machine learning with the Apache Ignite. So these are available on the GridGain website and on DZone as well. So kind of an introduction, and then looked at linear regression a few weeks back. Just the last article published a couple of days ago, looking at KNN, K nearest neighbor classification, and there's other content that's in the pipeline as well. So this is a very useful kind of addition, because today, to get valuable business insights, sometimes we need to apply these kind of machine algorithms. So in financial systems, for example, fraud is still a big problem for a lot of banks and building societies, these kind of institutions that deal with money a lot. And so having the capability to kind of intercept these suspicious transactions, if you like, as they arise, and be able to intervene quickly, is got to be a useful, something very useful. And again, Ignite can now support a lot of these machine learning capabilities in place. So whatever data that you've got Ignite storing, you can apply machine learning algorithms on that data now. Previously, the way to do this was that you had to do ETL. You take the data out of Ignite, you use third-party tools to process it and work on it, and that can be expensive and time-consuming. You might have a lot of data, and the process of getting it out of Ignite and processing it, and then getting useful business insights and sort of analytics, or being able to understand patterns, that can be a time-consuming process. Now Ignite can do this directly on the data that it stores, and that provides, again, the performance and scale that we get from that, the ability to run these algorithms in place. And again, there's some additional capabilities that they've added recently, this notion of partition-based data sets, for example, very useful for machine learning, because often machine learning is a kind of an iterative process. And context changes, the data may need to be modified as we are doing certain types of processing. And Ignite, because of its cluster computing, gives you a lot of flexibility. So if, for example, some parts of the cluster go down or are unavailable, your machine learning jobs can still continue. Okay, I mean, there's some real benefits to that. And it's something that I've covered in the blog articles that I've published recently. Okay, so that's a fairly broad, but hopefully reasonably detailed overview of Apache Ignite. And let me briefly just stop there for one moment. And as promised, so I will show you just quickly. Okay, so this is the landing page at the Apache website. So this is just ignite.apache.org. Lots of useful things that you can find here. It says, features, use cases, documentation, community, and so on. And notice that right in the top right-hand corner, it says here screencasts. Okay, so if we click this and just drill down for a moment and just take you down to the bottom of the page here, where it says here, Ignite Web Console, automatic RDBMS integration. There are 3 videos there, okay? So roughly 10 minutes of time, and 10 minutes of your time, and you'll be able to see how Ignite can integrate with a relational backend. I think MySQL is the example used in these videos, but what Ignite can do is it can automatically generate the code. All you need to do then is simply plug in your credentials, your username and password for the relational system, the IP address of where the server is running, and the port number it's running on, and that's all you need to do. And once you do that, and you've specified what particular tables that you want Ignite to manage for you, then what we discussed a little bit earlier on in terms of updates in the relational system are reflected automatically in Ignite's cache, and then changes in the cache propagated back to the relational system as well. So the two are kind of kept in sync. Very, very useful. And again, as I said, 10 minutes of your time, and you have the opportunity to see how this actually works in practice. Okay, let's switch back to the slides and move on. Okay, there we go. All right, so let's have a look then at clustering and deployment then. So Ignite has a number of different nodes that actually run, and some of these are server nodes, okay? So they actually, as it says, they act as containers for data and computation. So these are where the data are actually stored and where the processing can be done. The other thing is we can have client nodes as well, okay? And these can be a variety of different, so this could be so like a Java or C++ or .NET, for example. We could use JDBC, ODBC as well, REST interface, something that connects to our cluster, requests some work, or initiates a job, something that needs to be run. There is a third type of node as well, service node, which we're not going to discuss today, but this is something that runs a service. And it can be the foundation of your microservices architecture as well. So again, we've got some presentations, and this is something we, if time permitting, we'll have the opportunity to discuss in part 2, if you're interested. Okay, so we'll look at that. There are a number of ways that we can deploy nodes as well. Okay, because Ignite is Java-based, so we can have a JVM can number of JVM processes running, and we can initiate and sort of like one node per JVM if you like, if you look on the graphic on the right hand side, or we could actually run multiple nodes on a particular JVM. There may be circumstances you want to do that. So there's quite a bit of flexibility in terms of how to do this. The other thing is that anywhere that Java can run, Ignite will run. So I've purchased one of these Raspberry Pis late last year, and then I had the opportunity to test it out a little bit. And so a Pi comes with a cut-down version of Debian Linux. It has got Raspbian, and it's an ARM-based architecture. So there is an ARM-based version of Java, and I was able to do download the binary distribution for Ignite. I was able to unpack it, and I was able to run an Ignite cluster node on a Raspberry Pi, and and I could network that with my Macintosh computer as well. So there you go. I've got a very small 2-node cluster, running on 2 different platforms, and by setting up the how the clusters nodes are able to find each other to form this cluster, it's very simple to do. You can do it either directly through code, or it can be done through some configuration files, which we'll look at some examples very shortly. So Ignite will run pretty much anywhere. Anywhere with Java run, it should be able to run just fine. And you can deploy it in the cloud as well. And if you are into containers and Kubernetes, it will run within that environment as well. Again, we have presentations, documentation, show how to set this up. So very easy to do. A lot of flexibility there. Okay, so let me just show you a quick demo then, okay? And again, we'll launch the web browser just to show you where this demo code is available. As I promised a little bit earlier on, I mentioned that I would show you where you can download the code. Now, obviously, you don't have the time to install it and follow along, but after the webinar is completed, please feel free. So my colleague, Dennis Magda, okay, so if you go to github.com/dmagda, okay, so that's Dennis Magda, dmagda, and you have the opportunity to look at Dennis's various projects. And if we look at repositories then, of which he's got 14 at the moment at the time of this particular webinar, we scroll down a little bit, you'll see there that Dennis has got something here called IMC Essentials. Okay, so if we just again click on this, we can see here that this particular project is available, and actually Dennis worked on this a little while before. You can see sort of 7-8 months ago, but we can clone or download this. So this is the project that I've actually downloaded myself. There's a pom.xml file, so within an IDE, for example, you just easily create that project, which I've done here. Okay, so here is that very same project which I've loaded up, and it's here I'm using IntelliJ. Okay, I think that other IDEs would work as well, but this one just happens to be one that I've been using for a little while now. So in this particular case then, so if we have a look then at what I'm going to show you, so I'll show you how I can launch a couple of Ignite servers directly from within the IDE. Alternatively, this can be done from the command line as well, or a mixture of both. Okay, but today we'll just do it from the IDE just to show how easy it is. I'll show you quickly the XML config file as well, and then there's a couple of other smaller things which I'll show you. So there is this kind of web agent that needs to run. It can then connect to the cluster, and then it allows me to connect a browser which provides some information. We can look at CPU utilization, you know, get some cluster information, and have actually the opportunity to run some queries directly within that as well. So from the IDE then, one of the things that we have, and hopefully you'll be able to see it, I'll try and zoom in a little bit there, so I hope that's a little bit better in terms of visibility. So one of the things that we have here, if we look on this left-hand side, so we've got a couple of these folders: compute, key value, machine learning, model, persistence, SQL, and node startup. So node startup is just what I'm going to run, and I'll do that a couple of times. So we'll get a small cluster up and running directly within the IDE. So let's start one, first of all, okay, and then just give that a moment or two. So there we go, that's launching. Okay, just bear with me. There we go. So that's up and running. And at the bottom here, it tells us servers equals 1, clients equals 0. It's picked up the fact that this Mac has got, you know, it's 4 CPUs, and it's using the default heap size of 1.8 gigabytes. So, I mean, these things are configurable, okay? So that's fine. And then let me just launch another instance of this as well. So now we'll do another one. Okay, run another one directly from within the IDE, and just give that a moment or two to start up. Okay, so there we go. So that started up. So now both of these servers have found each other. So the information I get here is that servers equals 2, clients equals 0. That's okay. And then if I look back at the first one, and again, if we scroll down a little bit here, there we go. At the bottom, again, this node has found the other one as well. So again, it's updated its status to say that now there are 2 servers as part of this small kind of cluster that's running within my IDE. Now, one of the things, so if we have a look at the code for this, it's very, very straightforward. Okay, you can see it's very, very short piece of Java code. So we're using this kind of XML configuration file here, and we can have a look at this. Okay, so if I click on this, so this has got a little bit of information here. So lots of sort of configuration and parameters that we can specify here. One of these things is this service here, which is it has the property name IP Finder. So in this particular value, in this particular case, the value that it's taking is it's using localhost, okay, 127.0.0.1, and then it's got a port range that it's also got specified here. So in the event that I want to set this up in a distributed environment, for example, then I would modify this information to reflect that appropriately. So I can use multicast, I can use static IPs. In Kubernetes, for example, I would set up some kind of IP Finder service. Okay, again, as nodes come up, they need to be able to find each other. So in this case, just through a simple sort of configuration, I can modify these values and deploy this cluster-wide, and as nodes power up, they use this same configuration file and they'll be able to find each other, and I can form my cluster. Okay, so that's one of the things that I can do here. Okay, so let's have a look then. So what the other two things quickly that I can show you here is launch the web agent, and I'll show you the console as well. So now I've got a cluster of 2 nodes running within the IDE. In order to get some additional information and be able to look at some sort of statistics, CPU utilization, as part of the Ignite distribution, there is this thing called a web agent, okay? And by default, it doesn't run, okay? It's something that you need to unpack. On the Windows platform, it's a sort of bat file. On the Mac or sort of Unix or Linux-based environments, it's just a simple script. And in this particular window on the left-hand side, I've got this, and let me just launch that. Okay, so it just takes a moment or two to come up. So what it's done here is, by default, it will connect to console.gridgain.com, which it did successfully done. And it's picked up the fact that I've got a cluster already running, which consists of 2 nodes, which is correct. Okay, so those are the 2 nodes running within my IDE. So that's absolutely fine. Now, from a browser, let me just pull something up here, and let's just go to this console.gridgain. Oh, there we go. GridGain.com. Okay. Now, this is something that you can register for and sign in, and it isn't necessary to have this running on GridGain's website. I mean, I'm just using this for convenience, right? So in a production environment, this would be running within your own environment, behind your firewall, okay? So this is just for convenience. It's just simply to demo and show you the concept. In reality, if you were to do this yourself, you wouldn't be using it outside your firewall. But here we've been able to pick up the fact that we've got some CPU usage, heap sizes, for example. And if we scroll down a little bit, here we've got some information. For example, it tells us there's 2 nodes running. It gives us a bit of information about them as well. They've been up for a couple of minutes. And if we scroll down a little bit further, we can see that there's pretty much nothing else running at the moment. So there's no caches, no computations, no events, and so on. So there's nothing particularly happening at the moment. A little bit later on, when we run some code, we'll switch back to this and see what the status is and what's happening. So a useful way to get some information about what's happening. Now, one of the other things along the top here, we've got some other things that we can do. So configure clusters, caches, queries. Okay, there is an opportunity to create a notebook if we want to run some queries, for example. And I'll just pull up one of my older notebooks. So here, for example, it gives us the ability to run SQL, for example, directly from this browser, connecting to a particular cluster, and presumably, you know, we would have set up the necessary tables, and we can run those SQL queries directly from the browser if we need to do that. Okay, that's fine too. So the main thing we'll focus on today is the monitoring and the dashboard. Okay, so okay, let's just switch back to the slides again. So we've done that, and let's again launch this and move on a little bit further then. Okay, so distributed storage. So we talked about the ACID transactions a little bit earlier, these lock-based transactions. So Ignite supports those, as well as lock-free optimistic transactions as well. If you're interested and you work in the Java space, this is based around JCache. Okay, so this is again standards, industry standards, whatever the way that Java has done it. Ignite builds upon those concepts. I briefly mentioned the distributed partition hash map, okay, which is the way that it uses to distribute the data in the cluster. We talked about third-party storage caching as well. particularly useful if you're working with a transactional system such as a relational system, but equally you can work with HDFS and NoSQL as well, although the consistency kind of issues there would be different. I mean, these are things that you would have to think about given the fact that many of these products are eventually consistent. Okay, so the guarantees are not the same as they are within a transactional environment. Okay. All right, so I touched on this already a little bit earlier on. So the idea is that, you know, say we've got a cluster of a couple of nodes. The way that we store our key value within Ignite then is we use these put operations, and in order to retrieve them when we do get operations. And then we can do bulk operations as well. For example, we can batch together a lot of you know, key value entries that we want to store all in one go, or we want to retrieve in one go. We can do that as well. So it's not sort of individual commands that we necessarily need to execute. And there may be performance trade-offs as well that we can think about, where it makes it necessary to batch operations together, maybe a lot faster than doing individual sort of operations. So the key thing is then, how does it actually figure out where to store this? Okay, there we go. So the way that it does this, and I may have mentioned caches already a little bit, but Ignite uses this concept of partitions. And partitions are what are actually stored on server nodes. And specifically, we can sort of visualize it a little bit like this, okay? So a cache is something that is cluster-wide. Partitions are sort of atomic. They are the units where you can see here, we've got two stored within this particular cache. And think of a cache a little bit like an aggregate, a collection. You know, you could view it as a relational table if you like. I mean, you can see it in that sort of way. But a partition is atomic. And here, these on the left-hand side for partition 1, for example, you can see that we've got some key values stored there. And then in partition 2, we've got other key values stored there. And again, depending on how we've sort of configured our cluster, okay, we may have backups of these partitions as well. Okay, we'll look at that very shortly. So we can create like a primary copy, if you like, and we can have a backup copy or multiple backup copies. So we'll look at that shortly. Okay, so the way that these partitions are distributed here, we've got two nodes again. So we've got, say, partition 0 on node 1, partition 1 on node 2, and so on. Okay, so we can create multiple partitions. Here we go. So we've got a number of these. So we've actually got 16 partitions here, from 0 to 15, and we've distributed them evenly across these two Ignite nodes. Okay, so the thing is that when we want to do the storage, then what Ignite does, as I said, it knows, it understands the cluster resources that are available to it, how many nodes there are available, the address space that it has available to work with. By applying a hashing algorithm to the key, it knows which partition then to be able to store the primary copy of that. So in this particular instance, it's done that. It's applied a hashing algorithm to the key. It now knows that it needs to store this on node 1 in partition 2. Okay. In distributed systems, if we just have primary copies, say we've got a cluster of 4 nodes, as we have here, and let's say we've got 4 partitions as well, evenly distributed across these 4 nodes, numbered 0 to 3. In the event that we have some, say, failure, say perhaps there's a hardware problem, or let's say there's a sort of excessive delay being able to communicate with a particular node, perhaps latency or some other issues are intervening, maybe the network is down to some extent, we may lose one of these nodes. So in this scenario, for example, you can see that once the node has gone down, obviously any partitions stored on that node, they are gone as well. So we've lost partition 1. So that's part of our data, our cluster-wide data now, and that is no longer available to us. Typically, in distributed systems, as I mentioned a little bit earlier on, it's typical to store a backup copy as well. So here, again, we've got primary copies of these partitions, but now we can create some backup copies. Oops, sorry, seems to have, oh dear, sorry about that. Microsoft PowerPoint has crashed. My apologies. It doesn't happen very often, but there we go. Let me just, okay, cancel. Let's just try and open recent. There we go. Get our presentation back. Okay, there we go. It's back here. Okay, so my apologies for that. Sorry for the interruption there. Okay, so there we go. Hopefully no more problems. So here we've been able to create backup copies of the 4 partitions. And again, you see that the way they are distributed now. So if we lose that same node again, okay, notice that we've got a backup copy of partition 1 on one of the other nodes, and we've got a primary copy that was on the node that's gone down, but that's backed up as well on another node. So now here we go. You can see these sort of ones that are flashing that tell us that we've got backup copies. So each node then is kind of has a primary copy of some partition, but also acts as a backup copy for other partitions. So in this scenario, for example, our node has gone down. We've lost the node and its data, but because we've got backup copies and we've got this kind of replicas available, that's fine. You know, it enables us to still see all of the data that we previously had. Excuse me. Now, the other thing that Ignite can provide as well is that it has a rack awareness as well. Okay, so this is something that we want to ensure that we don't store backup copies in the same rack, so that you know, we've got our replicas distributed in the cluster in such a way that if we lose a rack, for example, then that doesn't impact, you know, has no serious impact in terms of our data access. So in this scenario, we've got a primary and we've got a backup. You could conceivably have additional backups as well if you wanted to. I mean, that's something that you could do. For small quantities of data, that might make sense, okay? Where these partitions are relatively small, they aren't storing a lot of data, you could conceivably copy every partition to every other node, you know, have multiple copies or across your cluster. That's possible, but then don't forget there are update issues as well, okay? Because these replicas need to reflect what data the primary holds. They have to be updated as well. That may involve network traffic, and that's something that you don't necessarily want. So fairly common within distributed environments to have at least one backup copy. Maybe scenarios where you need additional backup copies as well, that's possible, but it's something that you have to think about in terms of your architecture. Okay, so let me show you a couple of put-get operations then, and show you how to deal with data loss. Okay, so I'm kind of conscious of time. Okay, so we're already at 10:50, so we'll try and do this fairly quickly. So let me go here and back to our demo. So I'll close these couple of windows. All right, and I wonder if it's memory is the issue. Oh yes, so it's a little bit low. I think let me just free up a little bit of memory here. That's possibly the reason why PowerPoint crashed. So let me just give that a moment. So there we go. So we've got about 4 gigabytes available again. All right, so for this example then, we've got, let's have a look, key value, which is what we want. So put get example, okay? So remember, at its heart then, in terms of key value, Ignite supports put operations, okay, which is like sort of storing them, and get operations, which is like a read, okay? You're getting the data back. So in this example, remember, we've still got our cluster of 2 nodes running within the IDE, and now if I run this put get example, all it will do is actually just generating a list of, I think, about 1,000 numbers, and it just stores those in our cluster for us. Okay, so if we just run this application, just give that a moment. It's fairly fast, and it's a fairly small kind of. There we go. So it's done that fairly quickly. So it's actually a lot less than I thought. Not 1,000. Seems to be somewhat less. So what it's done simply is stored. It's got a loop, just generates a value, generates a key, and then stores that key value directly within the cluster. That's fairly straightforward. And again, if we switch back and have a look from our browser, we can scroll down now and see that we've actually got a cache here called put-get example. Okay, so it's got a total of 40 values here and 40 primary, no backup copies created here. Now, one of the things that we have is that because the data have been distributed, our key values have been distributed across these two nodes. If we lose one of these nodes now, because we've got no backup, that may have some consequences, okay? So if we go back here, one of the tasks that we can do here is now kill one of these servers, okay? And then see what impact that has. So let's take one of these nodes and then just stop it here in the browser, okay? So that should terminate that. Okay, so that's gone now. Now, if we look at this put-get example, I don't need to add these values again. So if I just comment out the part that does the put here, okay, all we want to do is to retrieve the data. It's already in the cache. And then let me just run this again now. Okay, there we go. Give that a moment. Okay, so we've lost one node. There we are. Now, we're getting some alarms here, okay? So it's telling us, okay, I can't access some of the data that you want. It's no longer available, okay? So some of these key values are raising these kind of alarms here because one node has been lost and we didn't keep backups. We didn't make a backup copy, and therefore, because part of our cluster has gone down, the data that was on that part of the cluster is lost as well. We can't access it now. There's a couple of things we can do to mitigate that. Okay, so from the code itself, okay, if we have a look, we can add a statement here, okay, to create a backup. So this line here just simply adds an additional backup, which would solve this problem. So if we bring that node back up and we recreate this, what it would do is it would give us a backup copy as well. So it would store the data across these two nodes, but would also create backup copies. And then in the event that we lose, in this case, our simple two-node cluster, what would happen is that all the data would still be available because the backup would also be stored on the primary. So, okay, so this would help in this particular scenario. Okay. Now, notice here, for example, that because we lost one node, it's gone down. The number of values that it tells us it's available is less than what we previously had just a few moments ago. Okay. So we've shown the data's lost. So, okay, I've shown you how to create a backup copy of the data. Okay, it's a simple one line that you can add to the code. And then again, you can configure it as you want. So in this particular case, I've just set it to 1. But if you wanted to, you could, create more than one backup copy. It's entirely up to you. But again, it doesn't make sense for large quantities of data to have, many backup copies unless it's something very, very important to you. The data are really relevant. All right. Okay, so let me switch back, and we're almost done. Okay, so a couple more slides to go through. Okay, distributed SQL. So the SQL support. If you're working with the 3 sort of top-level languages that Ignite supports really well, and that is Java, C++, and .NET, then you can work directly with SQL from these languages. If you're using something else, say Python or Ruby or something like this, then JDBC, ODBC is the way to go. Obviously, SQL support, very useful, as I mentioned right at the beginning of this presentation, particularly working with BI tools, for example. You want visualizations, you want to do analytics. The nice advantage is that the SQL support that Ignite provides Obviously, it works across the distributed environment. I mean, it's distributed SQL. And in this mode, then, for example, particularly with the native persistence that Ignite provides, you can view Ignite as a distributed SQL database. And there are some other products out there on the market that are kind of similar in terms of behavior and distributed data and working with SQL. So Google Spanner, for example, I think CockroachDB is another example. So this is, again, shows the flexibility that Ignite provides. Some other points to pick up from here. So full DDL, DML support, select, update, insert, merge, delete, create, alter, all of these capabilities are supported. The other nice thing is that, because it's pretty much standard, again, the ability for people sort of familiar with SQL, developers who know how to work with it, they'll be able to pick this up very, very quickly. I mean, the syntax, the way it's used, the other benefit that SQL provides is that it's very declarative. Okay, so you're asking the system, I want this data. It will go away and figure out the best way to retrieve that for you, and it will work in a distributed environment. So one other nice feature that Ignite provides is this notion of co-location of data. So where it makes sense that you're working with certain types of data, for example, you might be working with, say, manufacturing, in auto parts. So a car consists of a certain number of components and it has a manufacturer. So you might store information about the manufacturer and the cars that they manufacture together on a node. You can locate that data together. Therefore, when you're running queries in the distributed environment, it doesn't have to search across your entire cluster to be able to answer those queries. It may be able to do the joins locally on nodes, and that saves a lot of time and performance. So you get significant benefits in that respect as well. So on this particular diagram, again, it says indexes in RAM or disk. Okay, so Ignite fully supports indexes. Okay, and again, that's managed transparently for you. Now, of course, as you know, indexes are one of these things that whether you have them or you don't have them, the query will still work. So in one case, it may be very slow if you don't have indexes, but the query will still work. And again, if you've got indexes created, those are managed for you. So whether they are cached or they are indexes stored on disk, that's, for the developer, it's irrelevant and it's totally transparent. Okay, so just a couple of quick examples here. We're almost out of time. And so just looking at the connectivity, for example, all of these examples are documented, JDBC, ODBC, REST interfaces as well. These just standard sort of create statement there, you can see. Now here you can see with this particular create table statement, there are some additional keyword. There's a keyword with, template equals partition, backup equals 1, affinity key equals country code. So there's some small extensions there, which then give Ignite some hints about what to do with this table. So here we're saying we want to keep a backup of this, create a backup of this, it's important. And affinity key equals country code. So we may have an additional table that we want to store with this particular table, this idea of co-location, very useful. Again, store the data together, that makes sense. And then you can do joins across that locally without having to do a lot of shuffling or moving of data across your distributed environment. Data manipulation language, again, SQL 99. And here's an example of a SQL statement. You can see that select, from, where, group by, order by, descending limit. Okay, standard syntax, again, following the SQL sort of ANSI 99 specification. And again, because this is working across a distributed environment, all the benefits that you get in terms of cluster computing, such as fault tolerance and so on, all these advantages come into play. So Ignite manages all these for you. Okay, so there's a very quick demo here. So there is a tool that comes with Ignite. It's called SQL Line. Okay, so it's a very sort of small client that you can use. And we've got a cluster up and running. And all I'm simply going to do from this particular window, let me just pull these down a little bit and pull these down a little bit so we can focus on this particular screen. There we go. And it's just launching this thin client. Now I've got a third-party application connected to my Ignite cluster. You remember I killed one node, but I've still got one running. And here I've got some SQL commands here, which I can create tables, populate these tables, and that just takes a moment or two. And then meantime, if I switch over to the browser here you can see it's quickly refreshed, and now it shows me that I've got some additional caches, and these happen to be, the name of the cache is equivalent to what the relational table is called. So city, country, country language, and there's a fair number of entries here. So this third-party application, very simple kind of tool, allows me to connect to my Ignite client using this thin client JDBC driver. I can push SQL statements across. It creates a number of tables. That data is now in my cache, and I can query that now. I can run SQL statements from this tool directly if I want to. Okay, I showed you this a little bit earlier on. Create a notebook if I wanted to. Could run these SQL statements from here, or could do it directly from code, either from Java, C++, .NET, or using JDBC or ODBC. That's perfectly possible. Okay, so I am out of time, and I think we may have just a few moments, okay, for one or two questions, I think, Nicole. So my apologies, we've gone a bit longer, and again, apologies for the PowerPoint crash in the middle there, beyond my control. I'm sorry about that. These things happen. But happy to take some questions and do my best. And again, anything you want that we don't have time to cover today, please drop me an email, akmal.chaudhri@gridgain.com. Okay, over to you, Nicole. Thank you.
Thank you very much. So we'd like to give you the opportunity to ask your question to our expert. Type your question in the Q&A panel now. I see that we've received a couple of questions already. And one of the questions that we've received, is it possible to read and write data between Apache Ignite and a relational database?
Sorry, Nicole, could you repeat that? Is it possible to read and write data from
between Apache Ignite and a relational database?
Yes, it is. Yes. So I'm sorry if I didn't make the point clear. So yes, one of the things that Ignite can do really well is that it can integrate with a relational database really well. And so you can take data from a relational database, and again, you can define the tables that you want, which ones you want. Again, let me just quickly switch to the browser here. Okay, so these screencasts here, this is on the Ignite website, which I showed earlier on. This integration, automatic RDBMS integration. Okay, there's 3 videos there, roughly 10 minutes total duration, shows how to do this. So Ignite can integrate with the relational system. The data from the relational system can be updated through Ignite Cache, and Ignite will ensure that the backend relational system is kept consistent as well. So this is one of the great kind of things that Ignite can provide, is that it can integrate with the relational system. It can do this read and write directly with the backend relational system.
But that's all the questions we have time for today. We'll post our other questions if you want to hear what they are. Special thanks to our speaker today, and thanks to each of you for joining us and your participation. Please register for part 2 of this webinar series, which you can find on our website at gridgain.com. Thank you and have a wonderful day.
Yes, thank you, Nicole. And again, just if any questions, please drop them directly to me, and I'll answer them personally. I'll be very happy to help support that. And again, thank you for participating, and thank you to Nicole for organizing. And see you in part 2 in not too distant future.
Thank you. Bye bye.
Thank you. Bye bye. Okay, just drop in directly. Okay, so
So, Akmal, I think,
Yes, Nicole. I didn't even realize you're still there.
yeah, I am
Okay.
just converting the recording before I go. So that's
Okay.
so I'll say goodbye
Yeah.
and thank you very much for your time this morning.
Okay, thank you. Yes, sorry about the PowerPoint crash. Beyond my control. I mean, I normally when I set up my environment, I'm very careful to test everything beforehand. But obviously, I mean, this is a Microsoft thing. I have no control, and so these things happen in life. It's part of the nature of doing a live presentation. Sometimes
No
the things are
worries,
not
that's
in
fine.
your control, but
It was seamless.
that's the way it is.
Yeah, don't worry.
Yeah.
Thank you, Akmal.
Okay, thank you very much. And yes, so part two, I think should be okay. It's a bit more technical than part one. So I may need to get some help from Dennis as well to prepare for that, because I've seen his presentation and there's about 1/3 of it that I never cover because it's just too technical. But obviously I need to prepare for that, for the next session, because whilst I've delivered this presentation partially, from time to time, I've never done it as a webinar before, so I will make sure that I'm ready for that.
Okay, good. Thank you very much.
Okay, thank you for your help.
Bye-bye.
Bye-bye. Hi, dear.